So good morning, everyone. Welcome and thank you for joining our joint workshop, Cyber Threat Intelligence Empowering IoT Security, organized by the Secure Cyber Cluster. Our cluster unites various cybersecurity EU projects under an umbrella, a singular umbrella, to foster collective efforts against evolving threats and other challenges. My name is Christiana Kiperunda. I'm a project manager at 8Bells, a Cyprus-based R&D company, and also I'm the dissemination manager of SECANT, member of the cluster. And today I will be the moderator of our workshop. So today's workshop brings together 9 EU-funded Horizon 2020 projects, which have developed a cyber threat intelligence component, specifically focusing on IoT systems. And before going through the agenda and the structure that we are going to follow, allow me to pass the floor to my colleague Dimitris Caballeros from SER. He's the scientific coordinator of SECANT, and he will introduce the term of cyber threat intelligence. Dimitris, hello and welcome.
Good morning, everyone. Thank you. Thank you very much. I hope you can hear me well. Thank you, everyone, for being here. I think this is a very good initiative and very nice workshop we are having here. As we heard, the main topic, as Christiana said, is the cyber threat intelligence. And as I believe that most of you have seen in the projects, and we will discuss later on, one of the main aspects is to have actionable and accurate cyber threat intelligence. In order, this will be the benefit if they are both actionable and accurate, in order to have our security teams be better prepared in order to prevent cybersecurity threats. The main phases, as I could discuss, and then we will see each project how it tackled and how they approach each phase, is to collect cyber threat intelligence related data. Then from a plethora of sources, you can have it from the web, from social media, from internal organizations like CMs, intelligence feeds, from communities like ISACs, and from more. Then after you collect it, you have to process it and analyze it in a suitable manner in order to actually make them as a true cyber threat intelligence, and then to understand the attack behaviors, patterns, targets, and motives, enabling more accurate and faster security decisions in proactive manner. So in my opinion, at least, this is a very crucial aspect, and we need to see how in Europe can make it even better through our projects and research in order to strengthen the European Union. I give the floor back to you, Christiana. Thank you very much.
Thank you, Dimitris, for providing this insightful information. As I mentioned before, 9 projects will present their CTI component. I will share with you today's agenda. Okay. So our workshop is structured around 2 panel discussions, around 2 sessions. The first one includes presentations from 5 projects: CrossCon, Eratosthenes, Sentinel, Spatial, and Iris. And then a Q&A session will follow in order to receive your questions and feedback. And then we have our second session, which will it will host 4 demos, live demos from Arcadian, IoT, Electron, ETAN, and SECANT. Again, a Q&A session will follow for your questions. As you can see, our agenda is tight, and this is the reason I would like to ask from all the speakers to remain within their allocated time slots. And without any further ado, I would like to give the floor to the CrossCon project, and specifically Joao Souza, who is going to present security stack status and updates.
Yes, it's me. So I think you have the slides. Can you share, please?
I can hear you, yes, very well. And
can you
I
hear
will
me?
help you with your slides as well. Just a minute.
Can you hear me?
Yes, Joao, we can hear you.
Sorry, it was my connection. Okay. Can you present to me, please? Yes. And we are seeing the slideshows, not the. We are not seeing the correct presentation. We are seeing the second screen one log.
I'm sorry.
Can you change the display settings? Yeah.
Can you see your presentation now?
Not yet. It's the same yet. Is in the
apologies for this. I will fix it. So can you just tell me what you're just having in front of you in the screen?
Yes, it's like the presenter one, not the presenter one, the background, the presentation.
So you have the presenter view?
Yes.
Okay.
Now we see the correct slides.
Okay, good. Joao?
I can see it yet. I will just.
So you cannot see your slides?
Yeah, I see my slides, but I don't see the presentation.
But we see the presentation.
Currently, we have the slide with the agenda of today's presentation.
I don't know why I don't see. I just see the PowerPoint, nothing more. I don't know why.
Can you please try? Can you please try to share it from your laptop?
I will try to share it. Okay. Okay.
The rest of the participants can see the slides.
Can you see the slides?
We see Christina's screen, not Joao's screen.
Not mine.
No. Now we see
No,
yes.
No, yes.
Yeah, okay. So can I start?
Of course.
I apologize for this. So hello everyone. I'm here on behalf of University of Minho, one partner of the CrossCon project. In this presentation, I will cover the progress made in developing of CrossCon security stack. This is the agenda for today. The CrossCon, as you know, is an European project of 3 years. It already passed more than 1 year since the project started. It involves like 10 members of Europe between one large industry, 4 research universities and 5 SMEs. So for start, I would just quick recap on motivation, touching some similar topics that are involved with other projects in this workshop. So the first one is the lack of open source hardware solutions. We have seen that most IoT solutions rely on a proprietary hardware. So we aim to promote the transparency and foster creativity with open source solutions. The second one is related to the root and chain of trust. Since the amount of IoT devices being deployed have continuously increasing, as well as security services that run on it, they in some cases lack complete root and chain of trust, which poses several vulnerabilities. So we aim to establish a robust foundation. Next, the devices lack interoperability, which makes them to struggle when try to communicate between each other. So we aim to provide seamless connectivity. Next, there is high costs associated with developing trusted services. They require significant investment, advanced security expertise. So we aim to foster and promote these trusted services to a broader audience through an open, modular, and cost-effective solution. Lastly, and unfortunately, there are more and more vulnerabilities associated with trusted components. So we aim to strengthen these key trusted components. And overall, the objectives of the CrossCon is provide a secure ecosystem from root of trust through all components in chain of trust, is to provide memory protection and isolation mechanisms in both new and existing trusted execution environments, enhance trusted services, achieve security assurance with a lightweight to chain, and the main goal is basically design an open, modular, and high portable and vendor-independent IoT security stack that can run on a wide range of devices. So CrossCon project is divided in 7 work packages in which the development of CrossCon security stack is basically part of the P3 and is the main topic that I will cover today. So development of CrossCon security stack. CrossCon security stack is composed by 4 components. The first is the CrossCon TE, which aims to cover TE suitability and interoperability challenges by covering several TE models, architectures, and implementations. The second one are the trusted services, which CrossCon will consider the baseline ones and new trusted services, where the new are the proof-based authentication and context-based authentication. The third component are the hardware security primitives. And last one is the CrossCon hypervisor, which have as its core the BAU hypervisor. So the objectives of work package responsible for developing CrossCon security stack is basically define new trusted services, define a security tool chain, define a security manifest of different elements of the CrossCon stack, create this type of abstraction in different TE models, architectures, and implementations, create this type of isolation capabilities, develop a novel hypervisor mechanism, and develop a CrossCon TE for bare metal devices. So, CrossCon trusted execution environments. This part of the project is twofold. It is split between CrossCon TE isolation and CrossCon TE abstraction. Basically, the CrossCon TE isolation is due to the problem of TE suitability, since trusted execution environments nowadays face several vulnerabilities. The second part is related to CrossCon TE abstraction, which is also related to the problem of the interoperability. Since trusted execution environments are very heterogeneous today, we need to fix that. So, considering the literature review, CrossCon already explored different implementation and architectures like ARM, RISC-V, Intel, AMD. CrossCon already collected and analyzed several TE vulnerabilities. We're going through several sources like security bulletins and CV websites. More properly, these vulnerabilities here presented in several TEs of different vendors. Regarding TE abstraction, CrossCon will consider the global platform specification and will create this type of abstraction on the CrossCon new trusted services by checking if they comply with global platform specifications. So, CrossCon Hypervisor. As you know, Hypervisor are technologies used to implement virtualization, which typically aims to reduce the size, the weight, the power, and costs, while simultaneously guaranteeing temporal and spatial isolation. In this sense, CrossCon Hypervisor objectives pass through increasing the isolation and security guarantees, leverage existing open source virtualization solutions, and also aim to reduce the TCB and size of the attack surface. So for selecting the core of hypervisor, the CrossCon hypervisor, we compare several open source solutions like Bao, Xen, JLouse, Cell4, and Bao demonstrates as the one that's well fitted to be as the core of CrossCon hypervisor. This also results in the best paper student award. So hypervisor. Hypervisor is known as an open source static partitioning hypervisor. It follows a clean state minimal implementation and supports multiple platforms and architectures. During the project evolution, CrossCon already organized a workshop which was related to Bao. This workshop is available on YouTube for the ones that want to learn more about Bao. So in near future, CrossCon Hypervisor will bring new features to Hypervisor by like dynamic VM instantiation, virtual TE implementation, and multiple VMN support. Here on the right side, we can see the CrossCon abstract model, where partners basically try to merge all possible combination in security stacks on architectures like ARM and RISC-V. And these involve different privilege levels and different class of devices, like for low and high-end devices. The goal here was basically to get a unified level of abstraction across multiple hardware platforms. So, use cases. Jumping to the use cases of the project, the first one is related to multi-factor authentication, where CrossCon will use new developed trusted services to introduce new authentication methods based not only in something you are, something you have, or something you know, but also considering the environment context and behavior. So, use case 2 is to provide firmware updates of IoT devices, covering a secure update over the air. Use case 3 is related with commissioning and decommissioning of IoT devices. CrossCon here will bring robust commissioning and decommissioning procedures for applications, like ensuring higher levels of security and reliability in IoT device operations. In use case 4, we'll be applying remote attestation for identification and integrity validation of agriculture and named aerial vehicles, also known as drones. Using remote attestation, a user can ensure that UAVs is running, if they are running trusted software, and ensure that the hardware stack meets necessary privacy, safety, legal requirements. CrossCon will provide secure remote attestation on agriculture UAVs. Lastly, use case 5 will operate mainly on the reconfigurable hardware, also known as FPGAs, by providing intellectual property protection for security multi-tenancy. CrossCon will provide security multi-tenancy, sharing the workload of one tenant cannot interact with the workload of other tenant. So, during the evolution of the CrossCon security stack, CrossCon have actively publishing scientific publication, as well as some blog posts. If you want to know more about CrossCon, just get in touch and follow us. Thank you.
Thanks a lot, Joao. Now we are ready to go to our second presentation for today from Eratosthenes. Juan Francisco, are you with us?
Yeah, hi. Can you hear me?
Yes, clearly. Thank you.
Perfect. Do I share my screen?
Yes.
Okay. So, hi everybody. I'm Juan Francisco, and I'm from the University of Murcia. And today I'm going to share with you the Eratosthenes project and some kind of implementation to add privacy preserving techniques or the data that is shared in the threat intelligence reports. So I'm going to begin, and as all of you know, cyber threat intelligence is very important. It's any kind of information that contains any IOCs or any cyber observables that will help any organization or any entity to be prepared for attacks that occurs in other organization. So we can share information about this kind of attacks and the vector of attacks that occurs on the network, and we can prepare some kind of mitigation action or some kind of action that will allow us to take advantage of this kind of information. So with the wide growing of the IoT ecosystem, we know that that there is a huge attack surface, and also we know that in the low end of the devices there is a lot of protocols that they don't have some of them kind of robust security, so we must to secure them. And also here it takes importance the cyber threat intelligence sharing process. The threat intelligence sharing process occurs between using the platforms that are called threat intelligence platform, the TIPs. And as many of you know, MIS is one of them. CrowdStrike, Anomaly, ThreatStream, or Alien Bolt are some of these kind of platforms. This platform allows us to standardize.
Sorry, are you sharing your screen?
Sorry, I thought.
I'm not
sorry.
seeing.
Can you see now the?
Yes,
the
now we
presentation?
are seeing.
Yes.
But you see the PowerPoint?
Yes,
Now it's okay. Now it's okay.
Okay. Sorry. So as I was saying, the threat intelligence platforms allow us to establish a standard way of describing this information. So we can describe this information in many ways, and also it allows to add some automation mechanism, so we can in an automated way share this information and analyze it and react to it. But there is a negative side here, and is that the organization sometimes are reluctant to disclose this information because they think that if they share with other entities the information that some malicious partner has attacked his devices, this information could be used in counter of his purposes. So in order to attack this kind of problem, we have implemented an asset that will apply some privacy preserving techniques to the data prior to the publication in the threat intelligence platform. In this case, our asset works with MIS, but it is also prepared to work with the TIP, whatever it is. So the way this works is whatever entity that is the producer of the alert, that it could be a CM, it could be an EDS, or whatever that whatever entity that triggers an alert, will share this alert with the service, with our service, and this service will apply some data mining and big data techniques to the data itself, according to policies that these producers have sent as input, and it will post the event with the anonymized information in the MIS platform or wherever the TIP is. So the most important part in this component is the anonymization service. That is the service that applies the anonymization itself. And then we have here an identity management, so we can have an access control over the producers. Also, we have here the policy management module that will manage all the policies that are established by default by the producers, and also in case of a policy that is input here with the event, it will check if that policy is well formed and is well and suit the event or the report itself. And then this element will apply the anonymization and share to MIS through this connector. So, well, the techniques that we have implemented in this asset are some techniques that are from data masking itself, that is suppression and generalization. This technique doesn't have any mathematical base behind, but K-anonymity, K-map, L-diversity, and differential privacy, they have a mathematical base in them. So these first two are a more direct way to mask the information, to transform it. And these last four are more for a big load of data and more for disclosure of any big load of information. Also, for the use of this technique, there must be one, at least one data holder that knows the information and knows how to. These techniques will take advantage of the mathematical base behind them. So, for example, in case that you want to see the policies that we use, we have designed this simple JSON where we specify the techniques that we are going to apply here in the privacy policy files. And then here in the hierarchy policy, we define the way that we can transform the data. For example, here you can see a more complicated policy where we are applying diversity, and then we are applying here some differential privacy by noise addition. And the way it works is first the producer or whatever the EDS triggers the alert. The alert goes with a kind of policies. The policies are first the user is authenticated against the EDM. Then the policies are checking the policy management. Then the anonymization itself occurs here, and it applies the techniques that we have designed here in the policies over the event, the original event. And the original event is stored here in the secure database, but the anonymized event is published here in the MIS platform. So we have transformed the data. We have here the original data in case we need to some kind of auditability or recover that original event. And the result of this process is that, as you guys can see here, is an event. Here, for example, this event have like 1,000 objects, and it has some attributes that have been transformed by the policies that we have told the service to do. And in this case, this event is for financial, but this could have more use case, and this is suitable for whatever the use case is. So now that I have explained this, I will show you how we apply this asset in the Eratosthenes project. The Eratosthenes project is a project that is designed to want to design a framework that is decentralized, scalable, efficient, and privacy preserving IoT identity management, and that wants to assure that a device in a network in his entire lifetime will have the monitoring, recovering, and reaction to whatever attack, and that it has its normal working process in a secure way. So one of the parts of this project is that we apply the cyber intelligence shared process, and the way we do this is here you can see the architecture of the project. The important part here that we are talking is the CTA sharing agent, and the sharing agent is going to be interacting with the EDS, some mood management module, some trust managers, and whatever the module is that have some information that could be used in order to protect the device and to get new attacks. So I finish quickly here. The CTA sharing agent will be listening here the monitoring module, in this case the EDS, and it will take all the alerts that are coming from here, and with the policy that it have, and also the policy that the organization could create here, also by a front end that we have developed it. It will act as a proxy between the NIST platform and the monitoring components itself. And then this information is going to be published, some part of the metadata of this process, some info of the events that they that has been posted in MISP, and this information is also shared between domains through the CTI agent of several domains. And to finalize here, I show a more specific flow or use case where we use this. And this is a use case where an alert has occurred, and then we react to it by sharing this alert, but also with some privacy anonymization. I mean, with some privacy by applying these techniques over the original report. And then this will trigger a process where a manufacturer will receive this alert, and it will create another layer of, let's say, it will create a file where he says how his device must be used and how the behavior must be. So first of all, the EDS triggers an alert, detect something. It goes through the broker through the CTI connector, that is the proxy between the anonymizer and the connector. The anonymizer is, like I explained before, the part of the PPCTI module. And it receives this event. It will anonymize some attributes of this event in order to mitigate risks related to de-identification attacks. And it will post through the MIS that will trigger the process of synchronization with the MIS instance of the manufacturer of the device, of the IoT device. And then this manufacturer will analyze the thread, will analyze his device, and will create a mood file that will say, well, you can mitigate this in this way. So this final file is also announced in the MIS network, and it goes back through the mute management module in the origin domain. And then after all the process, it will interpret it, and it will send the countermeasures also to the broker, where other modules can take that countermeasures. So as you can see, we have added some little layers here and there of privacy. First, privatizing the data itself, and then using another mechanism as the mute, the manufacturer usage descriptor file, and using the MIS network. So I hope you like it, and yeah, this is all for my side.
Thanks a lot, Juan.
Okay.
And now we can move to the presentation from the Sentinel project, Bridging the Security, Privacy, and Data Protection Gap for Smaller Enterprises in Europe. We have with us Cyranoush Akarmazian from ITML.
Yes, thank you.
Cyranoush, can you hear us?
Yes, I hope you can hear me.
Yes, clearly.
Yeah, okay, great. Let me share my screen. Can you see my screen?
Yes, it's not in full screen though.
I will make it in just a moment.
Great. Yes.
All right. So hello everybody. My name is Cyranoush Akarmazian. I'm working from a private company located in Greece, ITML, and we are coordinating the Sentinel project, which tries to bridge the gap between cybersecurity, privacy, and data protection for business sector. So first of all, thank you for this initiative. We gathered one more time under the Secure Cyber Cluster and with all the project trying to create and develop innovative solutions in the cyberspace and also for data protection. And with this presentation, I would like to present the overall concept of the Sentinel project, what we have developed, and actually tried to validate and get additional feedback from potential end users and some feedback from their sides. The project is very close to its end, so it's our last actions in this respect. Anyway, you will see some interesting results from our end users. So before going to the Sentinel project and what does this project, I would like to just a little bit to share some thoughts about personal data and how it's important to protect them in order to safeguard fundamental rights of humans in the digital age. So the definition of the personal data is any information related to an identified or identifiable nature person. It's defined in GDPR Article 4. So it's all the information related to humans. It can be health, financial, online activity related information, demographic information, identifying in the persons or humans information like email addresses, anyway, anything related to these aspects are defined as personal information and personal data. And not only it's important in order to safeguard human fundamental rights for their well-being, but it is also important for any organization, enterprises. It can be business related or not business related. It's also important to protect personal data from perspective of several risks, like operational risk, financial risk, and reputation risk. And Sentinel actually is based on these, aspects and mainly to the questions how we can protect personal data and finally how we can comply with GDPR. Okay, so the motivation of this is the main motivation of Sentinel. We're focused more on private business sector, and it's supposed to help SMEs, MEs, which needs protection. Okay, due to the violation of individuals or customer privacy rights, due to operational downtime or the data losses, reputational damages or GDPR fines. And it's the purpose of this project is through the developed platform to mitigate risks, as I told you before, which can be operational, financial, and reputational. So the statement of the Sentinel project, it provides a complete privacy, cybersecurity, and data protection suites for business sector to achieve security and safeguard their customer asset in an affordable and efficient manner. And how we do this, we integrate security and privacy technology in a unified architecture, and where we try to automate GDPR compliance through the provision of recommendation for personal data protection and cybersecurity. Through these technologies and a unified architecture, we educate SMEs on the GDPR requirements and how they can achieve GDPR compliance, and we provide also several tools and services for real-time monitoring and threat mitigation. So the key driver of the Sentinel project is the GDPR Article 30, which is the record of processing activity. And just a few words about the processing activity. What is it? For somebody who it's the first time to hearing it, it's processing activity is a description of how an organization handles personal data. Okay, and it's an application based on GDPR rules. It is an application for many companies, of course, depending on the size or data types they're handling. And based on this main concept, we have developed the Sentinel platform. It is a simple workflow of 7 use cases, starting from the registration to the platform, SME registration, and creating a profile of each organization, then completing self-assessment workflows and acquiring policy recommendation. And there are some use cases through which we can receive security notification, incident report, and share, and consulting the knowledge base, which provides a complete set of tools, services that the user or the SME representative can check and educate themselves on cyber threats and generally the actions to mitigate cyber threats. Okay, these are the use cases. No need to go through all these. I would like to focus on the Sentinel offerings and value proposition, which is the most important part, how we offer our platform. So we separate 4 distinguished offerings. And the first of all is this, that the platform tries to educate and train SME representative to raise their awareness and on GDPR compliance and obligation, and what kind of measure they can take in order to approach to GDPR compliance. It provides a toolkit for evidence-based GDPR compliance. It provides link between the privacy requirements, measures, cyber asset configuration, and real-time monitoring. And based on these these offerings, it of course the most important part is we cut costs through the automation. So it provides a GDPR compliance check, data protection impact assessment. It provides a tailored recommendation for GDPR compliance and policies, as well as real-time monitoring for cybersecurity and privacy compliance. And finally, we have also a cybersecurity awareness and cyber range training. Again, here, the main purpose is to raise awareness and train SMEs to recreate the cyber setup of their organization and learn how to do cyber defense. A few words also about Sentinel validation. As I told you previously, although we have 2 dedicated, pilot cases, our partners, we have validated the platform also in real-world settings, facilitated by more than 20 distinct enterprises coming from outside and not being a partner of the Sentinel project. And they represent multiple fields like health and social care, accounting and finance, human resource management, from IT and IT security and data protection field. And all these individuals were coming from either being either basic or intermediate level of knowledge regarding GDPR and cybersecurity. Just some few words also the feedback that we have received. We were very excited of our achievements. Actually, we had last week our final SME-centric workshop where we demonstrated the platform, and we invited these end users to test the platform during the workshop, and we got very excited feedback from their side. Just a few words about the achievements. 2 questions. If they can find Sentinel useful within their company, and we got almost 65% yes, with 30% maybe answer. And the next question was if they plan to invest such kind of tools and services within their organization in the future. Again, very positive answer. So 47% of the end users they accepted that they can and they are willing to invest in such tools, and maybe 37% of end users maybe after 2 years, and only 16% of users they didn't know if they are planning to invest on such tools. Anyway, the results and all this feedback was are very promising for us, and we're very excited of our platform that we have developed, and it was we could test it in real life settings. This is all from my side. You may see our contacts. By the way, if some of you would like to test the platform, it's open and easily available for all of us. Just contact us and we can help you to go through the platform that we have developed. Thank you for your attention. If there are any questions.
Thanks a lot, Cyranos. We will take all the questions during the Q&A session following the end of the 5th presentation of this session.
Okay.
Thanks a lot again for your presentation. Now I would like to pass the floor to the Spatial project and Shen Wang from the University College Dublin. Hello, Shen. Your presentation is titled Enhancing Cybersecurity with Accountable Resilient AI, a human-in-the-loop metrics-driven approach.
Hello, everyone. I hope everybody can see my slide and hear me okay, right?
Yes.
Okay, great. Thank you, Christiana, and lovely to meet you all. So, good morning, everyone. My name is Shen Wang. I'm from University College Dublin, Ireland. So, firstly, I would like to give a quick, brief introduction of what is Spatial about. So, Spatial project, the full name of that is Security and Privacy Accountable Technology Innovations, Algorithms, and Machine Learnings. So as you can see from this logo here, so trustworthy AI solution is the key. And we're trying to use this solution to address the privacy, resilience, and accountability, 3 cornerstones for this project. And we want to propose a trustworthy AI solution that is ethical, lawful, and robust. So, which means that the innovative part of our proposed solution are not only technical, but also hopefully will potentially create some social impact in the long run. So our project starts quite a while ago and will be due August later this year. This project involves 12 partners from different European countries, across different universities, research institutions, and SMEs. So this is the overall work package structure for spatial project. The role of UCD, University College Dublin, for us is mainly to bring the bridge between the technical requirement and a more integrated spatial platform development. So, which means that our role is leading this work package, trying to propose something that is scientifically new and also promising to be further developed in the near future and also tested across different use cases. So in particular, our role is firstly propose a set of metrics to measure how good is your model, how secure is your model, how privacy preserving is your model, and how accountable is your model. So firstly, we are going to propose the metrics, and secondly, we need to propose a process that can embed these metrics and then plug into the existing state-of-the-art development process and trying to make the existing AI algorithms for cybersecurity solutions more accountable and resilient. Okay, so motivations. Well, as most of us may aware that the AI solution so far recently focused too much on increasing the model utility, which is the accuracy of the model, while ignore the accountability, security, and privacy. So while ideally we want to propose a solution that can achieve a perfect effectiveness on all of these 4 aspects, but actually practically we actually need to make a trade-off among those, as shown here, that for example the explainability part of the AI models are actually decreasing if we want a very powerful model. So normally a very powerful model, for example, deep learning based model, are based on the large training data set and also the large scale of the model itself. So normally we consider it as a black box AI. So it would be good if it can provide a very high accuracy, very high model utility, but to some extent, when it is not performing well, then we really need kind of explainability for people who can understand why the model goes wrong, especially for some critical tasks like autonomous driving, right? So the first motivation for spatial is there's actually no perfect solution, and we need to focus on these 4 important aspects while proposing the trade-off solution. Secondly, we find that developing accountable AI or trustworthy AI solution, human perspective is the one of the most important factor, and we would like to focus on our stakeholders, focus on the technical experts or internal stakeholder, because we find that the existing explainable AI solution, although it's promising, but it's mainly, according to the recent paper, is mainly for the internal stakeholders to tune their model, to make their model more robust. So we thought a more stable trajectory for spatial is to focus on explainable AI, to to address the internal stakeholders' needs first, and then gradually extend to the external stakeholders, which is non-domain expert end users, and making them more confident in using trustworthy AI solutions. Okay, so this is the spatial process we propose. As you can see here, in total, we have 4 steps, while the 3 steps are all need the internal stakeholders engagement. So generally, the first step is we need to meet with the use case owners to set a realistic trade-off objectives. In this case, maybe we help the use case owners transform from focusing on the model utility only to a balance between the model utility and accountability. And the second step, we actually have already proposed a full set of the metrics in terms of model utility, accountability, resilience, and privacy. But we need to discuss again with the use case owner according to the preset, the trade-off objectives, and to pick a subset of it. Because in some cases, the metrics are not available for computation, for the data access issues, and so on. And step 3 is basically using the existing AI pipeline from training to testing to deploying and to fine-tuning. While specifically for the fine-tuning part, we need to bring the internal stakeholder back to the feedback loop and seeing the result, and then discuss for the further improvement actions. Okay, so so far we have preliminary results for all 4 use cases that our spatial project is focusing on. The first one is from Telefonica. Basically, their use case is federated learning. They provide a service called Federated Learning as a Service, FLAS for short. So their use case is basically want to focus on the balance between the model utility and privacy preserving. Well, so I won't go into much details on that, but I just want to highlight quickly what is the key result. So we find that firstly, we find when we add a different level of noise to the model, we can find that the privacy is preserved very well, while the accuracy, model accuracy still maintains the high level, which is great, but only for some specific data sets, in this case, another NSLKD data set, but for some other data set, for example, MNIST data set, it's very, very sensible, which means the accuracy might drop to the very low, unacceptable level. Well, so this is the one conclusion. The other one interesting finding is we propose kind of privacy metrics called user diversity, which means basically for federated learning, although all the clients might be different from each other, but we want to hide the user diversity so that it is harder for the attackers to influence their privacy, client privacy information. So we can find that the user diversity is actually kind of decreasing, or similarities actually increasing quickly with the increasing number of training epochs. So we would like to suggest the user of FLAS that pay more extra attention on the first few training iterations. While the second use case is from Montemarsh. The company specializing in providing IoT solutions on the 5G scenario. So basically, we get a data set captured from their in-house IoT 5G testbed. So this network traffic coming from different user behaviors, including video watching, including the interactive messaging, also including the web browsing. So the AI solution here is trying to identify which is which. So the spatial trade-off objective here is trying to balance the model utility and accountability under the very typical AI model evasion and data poisoning attack. So basically, we use XAI and find that XAI is actually trying to help to detect if this current AI model is under attack or not. And we also find that this accountability behaves differently under different AI models. While the third use case is from Fraunhofer Focus in Germany. Basically, they have an emergency call system of voice over IP based on voice over IP infrastructure. And the current AI solution is trying to capture the patient's heart beating, let's say heart beating sensor data, and then trying to automatically trigger the hospital side. If there is any abnormal thing happened, then the hospital will send the ambulance and to the patient's location. So that's what this testbed is about. While what we are trying to build on the top of that is because the existing AI solution will have a lot of false positive cases. So we would like to add the accountability part and to see if it is really the data showing some abnormal behavior of the patient's health condition, so that it's really need to send ambulance or not. So it is currently work in progress. We have used AI algorithm to achieve a very good result, but we also use different XAI methodologies and find some different explainability symptoms. But we are currently working on engaging the domain experts, which is doctors, in designing a more accountable solutions on this use case. While the last use case is from WaySecure from Finland. Their use case is basically the maldoc detection. So while what we found is actually we use XAI, and we find that there are a couple of training data features that are very sensible to the AI attacks, but are not very important for making a good AI decision. Then we remove this number of features, and we come up with a resilient solution, AI solution, that we can actually achieve a similar amount of accuracies, but we actually have the all the resiliency metrics much higher. Okay, so that's a quick overview of the spatial project so far. So thanks for listening. I'm happy to take any questions later on if you have. Thank you.
Thanks a lot, Chen, for your presentation. And now our last presentation for the first session comes from the IRIS project, Innovations for Timely, Semi-Automated, Secure, and Interoperable CTI Reincidents. We have with us Giovanna Pilali from ICCS, Eleni Dara from CERT, and Sofia Tsekeridou from INTRA. Welcome.
Welcome, Christiana. Thank you very much for this slot. So we are going to present you, as you said, the presenters, me, Eleni Dara, and Sofia Tsekeridou. We're going to present you a part of our work conducted under IRIS H2020, with the title Innovation for Timely, Semi-Automated, Secure, and Interoperable CTI and Instance Information Sharing and Reporting, Enhancing Awareness and Collaboration among need-to-know CI operators and search. The work is enormous, but we are trying to enhance the pace of the presentation. So the aim of the project is to deliver a platform with a framework supporting a European search in close collaboration with CI operators to detect, share, respond, and recover from cybersecurity threats and vulnerabilities of IoT and AI-driven systems. We focus primarily on cyber resilience in transport and mobility, as well as energy sector. So this is the high-level architecture of IRIS. You can see several modules and tools. The most, let's say, centered and important are these of automated threat analytics that take all the threats and events detected from infrastructure and send it to the enhanced research ecosystem in order to be processed, enriched, visualized, and stored. And we can elevating collaboration among end user, and we can dive into collaborative threat intelligence module in order to see cyber threat intelligence sharing and storage and advanced threat intelligence orchestrator that is going to be presented later on in order to enrich and automate workflow execution of the cyber threat information, and then the data protection accountability module that is responsible for the privacy of the metadata of the event information. So the core innovation CTI are the automated and timely CTI and cyber threat incident information collection, the semi-automated and interoperable CTI workflows management and integration within ATA tools, dynamic CTI information enrichment, semi-automated, secure, and timely CTI and incident information sharing and reporting among need-to-know stakeholders, enhanced and timely cyber awareness and collaboration among need-to-know stakeholders, and we close the loop with the semi-automating response policies execution and acknowledgement of detected vulnerabilities and threats. Now, I will show you that we use some standardized cyber threat language in order to disseminate the cyber threat information within IRIS. We use PIX 2.1, and also in order to disseminate the responses through the search and CI operator, we leverage on Kakao playbooks to establish standardized, scalable, and consistency effective incident response procedures for common threats. From the earlier stage of the proposal, we identified some problems that probably the end users, search and CI operators face during their daily processes. Some of them could be the time-consuming processes in activities such as monitoring or waiting for alerts to arise, identification of abnormalities. The decision-making process also is a very time-consuming process, the variation of data sources, and the continuous enhancement of smart cities technologies that erase also, that enhance also the vulnerabilities that exist in these AI and IoT systems. For these reasons, we establish an advanced threat intelligence orchestrator that adheres security, orchestration, automation, and response in order to take input from tools and user input and elevate streamline operations, sharing procedures, response, and recovery. And this is the Advanced Threat Intelligence Orchestrator designed by ICCS. This tool consists by 7 sub-modules, 2 user interfaces. The other are the backend services, and also we have an ATIO database that stores all the logs from information visualized to the user interfaces. As you can see, this is the UI of the ATIO, and we use the open source tool called Shuffle. We can integrate all the tools from the project. Also, the user has the capability to create customized workflows, to use pre-made workflows, to change some of the parameters, such as endpoint steps tools, to use categorization tags in order to navigate within. Also, we have created the monitoring app that records all the end user modifications, additions, or deletions in a particular workflow that an end user wants to execute. Here, you can see a workflow. This workflow can be executed either automatically or not. The most important is that the workflow starts from the left to the right. Here is a webhook that can be triggered, and then the flows and all these processing actions happened automatically. So you can see here the MISP, then all the information sent to RRR, and then forwarded to the dashboard. And if we move on, here are some of the standards that I already presented. Thanks, Sophia. So here you can see the STIX 2.1 iris data model that we have already created, and the objects of this data model. And also here you can see all the elements that is used in order to have a Cacao response. The metadata are the main elements, and the workflow steps that integrate logic to control the commands to be performed and targets the receive, process, and execute commands, data markings that specify the playbooks handling and sharing requirements, and extensions that allow to gradually introduce additional functionality. And this is an example of a STIX Cacao instance. And now I can pass the floor to Eleni.
Thank you.
Okay.
Okay, thank you, Giovanna, for passing the floor to me. Good morning to all of you. I will give, let's say, a status of the CTI, the Cyber Threat Intelligence under the IRIS project. It is actually worth mentioning that the CTI is generated from indicator of compromise, the IOCs, and the tactics, techniques, and procedures, the TTPs. They also offer basic information about the attacks. The TTPs describe in a more general, let's say, way the attacks, the way of the actions of the attackers. The CTI can offer the organization to mitigate the damage caused by the attackers. Under the IRIS project, the CTI module focuses on the collection, the sharing, and the reporting of the threat intelligence to search and research, while at the same time it builds taxonomies and ontologies targeted to IoT and AI-based related attacks. As mentioned, give me a second to change the slide. Yes, thank you very much. One of the key objectives of the CTI in the IRIS project is the taxonomies and ontologies generation. This is achieved following this presented the pipeline in the diagram. The CTI, first of all, is collected from both the internal and the external sources. When we are talking about the internal sources, we mean the information received from the tools, the other tools that described in the architecture earlier on from Giovanna. And the external sources, we mean the vulnerability database, the cert feeds, the proof of concept sources, etc. As far as you can see from the pipeline, the information is pushed in MISP as an input from the Advanced Trend Intelligence Orchestrator. The gathered information is correlated using a rule-based and machine learning-based techniques. The main point is to find associations between data and intelligence. The data received are used to extract more valuable information, for example, the threats, attacks, and vulnerabilities for the taxonomy generation. NER, named entity recognition and BERT topic modeling, as well as pattern matching procedures are used, and taxonomies are generated. The generated taxonomies are used to update the existing ones, for example, the MISP taxonomies. More details I'll give you in the following slides. For the ontology generation, the REBEL model is used to extract relationships between the different taxonomies. The ontologies are developed and the merged one is generated by different generated ontologies. The terms of the merged ontology are used to update the existing ones. The existing ones are named Malone and IoTsec using a semantic search procedure. In the following slide, I'll showcase the taxonomy generation. In the next one, you will see the list of the previous one, the list of taxonomies that are stored in MISP. The MISP update, as I told you, is in this slide. You can see the CertXML taxonomy, and at the top down, you will see the update of the existing taxonomy. The visualization environment of the ontology creation is the one that I showcase now. You will see a merged ontology, the Malone, and the one that has been created from our tool. In the next slide, you will see the ontology generation from on the left from the internal sources, that is the tools that are used in IRIS project, and on the right part, the ontologies generated from the different external sources. And then in this slide, you see the update of the Malone and the IoTsec ontology, and how it is showcased in the after the update with the existing ones. And now I'll give the floor to Sofia.
Thank you very much, Ivana and Eleni. So now we'll be presenting actually the entire IRIS Enhanced Knowledge Service ecosystem that also encapsulates what Eleni and Giovanna have presented as well. So the key objective has been for this sub-module subsystem of the IRIS platform to extend the Melisetes version to open source platform, incorporating the IRIS CTI development so as to enable, as has already been mentioned, secure and efficient security information representation in standardized formats, STIX version 2.1 Cacao, but also a conversion to MISP objects. This, of course, leads to interoperability of communications of information within the IRIS platform for components, but also across IRIS platform instances, because the IRIS platform actually presents a distributed ecosystem. Of course, we allow in this way the secure publishing, sharing of AIT and IoT relevant CTI information. And we wish to enable the timely collaboration among the need-to-know stakeholders, according, of course, to the different directives and NIS2, SER and CRA. The aim is to promote wider awareness, better preparation, detection, and response capabilities, so the full cycle. To define setting policies and communities of trust, to share sensitive information, but also to collaborate and manage potential vulnerabilities as well as attacks, which is most pertinent. and to securely communicate and collaborate within and across CERT authorities and CI operators. So our main stakeholders actually for using the platform, and we have two flavors of the M ecosystem, are the CERT authorities and the critical infrastructure operators or operators of essential services. We provide for that aim an advanced and unified dashboard that enables incident reporting, situational awareness, response actions, configuration, and recommendations, offering, of course, authentication, authorization services, and roles and rights management. And as I said, the M ecosystem is a distributed architecture. So we have instances and different flavors deployed at the stakeholders' premises. So we have the MF flavor for CI operators and operators of essential services, and the MF flavor for CERT authorities. Of course, we capitalize on the Melissa's open source software, but also MISP, as Eleni mentioned, and SAFUL, as Giovanna mentioned. So you see here what is the utmost aim is to enable actually true information sharing. I know it will be very quick, sorry for taking more time. True actual information sharing, but in a timely manner, secure, and as well as to enable the collaboration among the necessary stakeholders. So you see here, for example, that if an energy CI operator experiences that is running an IRIS at, I don't know, my mouse is on, yeah, an IRIS instance, a platform instance, then detects the automated threat detection components detect a threat. Then we are given the capabilities for this to be CERT in interoperable formats, takes Kakao to the National CSERT Authority that runs the IRIS M instance. And then the National CSERT Authority may choose and desire to share this with other energy operators in the same country, or even with other CSERT authorities in other countries, etc. So the information is shared in a secure manner to the need to know according to the protocols, of course, that and legal procedures that apply in each country. And the response and the capabilities to manage and raise awareness are much enhanced. So as you've seen here, I will not say much more here. We are able, as presented, to a report to gather the information, to enrich it, the CTI information, to report it to the right authorities, to allow response, mitigation actions, and associated workflows management. For some cases, automated response actions can be configured. For other cases, the decision how to handle the situation rests with the security officer, the critical infrastructure operator, in collaboration with the CERT authority. Okay, I will not. Of course, we need to build trans communities. This is done using the capabilities of the enhanced of the Melissa's ecosystem and the setting groups. You see here the two flavors of the ME platform. The one for the critical infrastructure operators, who can view what the automated attack detection tools have detected. And they can actually, you see here, status pending. They can actually open the respective report and see and manage it. Either, for example, enable the right response or dismiss it if it is not something that needs to be handled. And you can see here, for example, they can receive also on the top right notifications when something actually is detected that a tool. So it is quite timely received, and they can click on it and do the right actions. And they can even configure automated response policies for certain types of threats and attacks or vulnerabilities that you see here. Or even they can initiate a vulnerability scanning of a new asset that has been added in the infrastructure. Come on. And here you see the full view, the detailed view of specific threats that have been detected and received, and the risk of that the risk that is imposed by that threat also is denoted. For example, for the first one is 24%. The operator can approve or decline according to how critical or perhaps nothing to cater for. When, of course, it is approved, the status is updated. This information is shared to the trust circle, the sharing group. So the CERT authority can automatically receive this information and the status for this information. And then they can communicate and collaborate to see if something is too critical, how to manage it, for example. Okay, so you see here some of threats have been approved. You see the status on the right. Come on, and this is the CERT authority. Of course, the CERT authority is managing. It depends on the jurisdiction of the CERT authority, which is a national CERT is for the entire country. Here you see the CERT authority of Spain, and what information has been received up now. There are a lot of statistics and visualizations for the threats that have been detected in the past period and how they may have been managed or not. And here you see also the CERT by TC. So it is actually which trust circle, which sharing group actually has disseminated this type of attack or vulnerability to the CERT authority. And then, of course, they can communicate with the response actions. Come on. And this is the full view also for the CERT authority for a specific threatened attack. They can also be notified when the status of the attack has changed based on what response policies the CI operators have followed. Okay, this is all from our side. Thank you very much. So we are happy to answer any questions you may have.
Thanks a lot, Sophia, Giovanna, and Eleni. It's time to open up the floor for the Q&A session. So feel free to direct any questions to our 5 projects, CrossCon, Eratosthenes, Sentinel, Spatial, and Iris. Do you have any questions for them?
Hello, can you hear me?
Yes.
Okay. My name is Christo Kostansky from Ethos Evident. Actually, I like a lot of presentations for today. I don't know if we have 5 minutes for the Q&A session. I observed that we have actually a very wide range of potential CTI data, which can impact. So let's say if we take from CrossCon the low-level IoT platforms, we have vulnerabilities there, but they can impact higher-level components and systems. So on these higher-level components and systems, applications, operating systems, services, infrastructure, communication protocols, implementations of these protocols, they have more vulnerabilities on the higher-level stacks. So then we go to the AI. Very interesting on the AI level from the University of College Dublin. It was presented. So there are also some metrics there where I can see that can lead to some CTI data, some either vulnerability, some information about how security and how privacy issues can be seen in some AI models. So this range of vulnerabilities and CTI data needs to be processed and make use of it. So to me, it's very important, interesting to see if the position of the other people, how they see the use of this wide range of information, how that can be used and connected together. Hope it was clear enough.
Yeah, I think your view is definitely correct, and I strongly agree with you that this data being used by AI models has to be carefully monitored and also has to be accountable, which is one of the key focus of our project Spatial. And if you're interested in these metrics, so we actually have our key deliverable that is related to the metric definition released here. So I would like to post the link here. So that's the 2.2. So because we are mainly, I mean, as UCD, we're mainly taking care of the explainable AI part. So, but we do have some strong collaborators, for example, WithSecure, who has been providing these cybersecurity solutions over decades. They propose a selection of the vulnerability metrics, which turn out to be very useful. So, as far as I know, is basically starting from the existing resilience metrics and trying to measure how much effort that the attackers that is going to take for getting the information of the target AI system, and how much effort that as a defender should make to defend against the certain AI attack. Yeah, again, thanks for your question.
Thank you. Yes, definitely this is an area which is still ongoing, and many important CTI management and utilities will be developed in this area, I understand.
Yeah, thank you, Risto.
Any other question? Okay, if not, we are ready to begin with our second session, and I go directly to Arcadian IoT, Machine Learning Assisted System for Cyber Threat Intelligence. Han Wang, welcome.
Hi, yes, let me share my screen. Can you see my screen?
Yes.
Yes.
Okay, great. So yes, good morning, everyone. My name is Han Wang. I'm a researcher working in RISE, Research Institute of Sweden. And so today I'm going to present our work on CTI, which is we call the Machine Learning Assisted System for Cyber Threat Intelligence. So first of all, I would like to introduce what is Arcadian IoT, and it is a Horizon project that we aim to develop IoT system towards decentralized and transparent and user controllable privacy in three real use cases. What is three real use cases? They are emergency intelligence and the drone monitoring and the medical in IoT. And we have 3 vertical plans and 3 horizontal plans. And our CTI component is located in a security plan that tried to help this project to share our get alerts and all the information that is about threat intelligence. So before we start, and we like to introduce a bit what is the MISP. I think you have heard a lot of in the previous presentation, but I would like to go more in detail because here we are actually working around this. So MISP is Malware Information Sharing Project. It's a threat information sharing platform that's free and open sources and can collect data from different partners, tools, and it can also collect all the feeds from the public resources. And it also can normalize and correlate and enrich the data. Sorry. So the MISP is open source and is implemented in 4 different models. And first one is MISP Core. That's actually the main GUI. That's graphic user interface platform that implemented by the PHP, JavaScript, and Perl and Python. And they have MISP model. This is actually the model we can use it to extend our functionalities. And PyMISP is a Python library to access MISP platform via REST API. And you can allow you to fetch events or update the events, or even to delete, update any kind of functionality you can think about. And the last one is a MISP dashboard. It can show you the live data and statistical in the real time. And the terminology of this MISP is there are 2 main layers, and only just introduce some important objects here, like information here. One is events. Events is actually a calculation of centralized linking information represent as like the threat information. Like for example, the event can be the DOS attack, or it could be the malware hash function, or this kind of events that can be defined. An attribute is actually can see as an individual data points, which you can see as like an indicator of compromise. is to support the events. So one event can have multiple attributes. And object is actually the custom template for the attributes. You can define your own object, and you can wrap it as the like a feature set for the attributes. The context layer is we have a tag. We can label it to the event to have the further information. We also have the Glassy cluster. There's a knowledge base item used to label the events, and you have this cluster relationship. And so we have talked about like IOC. So IOC is actually indicator of compromise. It's like a contains a pattern that can be used to detect the suspicious or malicious cyber activity. This can be the attributes in MISP can be like a network indicator like IP address, or it could be the system indicator like a string in memory, or even a bank like a fraud transaction, or it could be the account details. And so this attribute can be anything, or you can like a tab, it could be MD5 or your URL. So it's different kind of information. All the information can be shared. And IDS flag, there's one attribute that's called IDS flag, that whether you can use this attribute directly to the IDS system. So what is MISP classes and relations here? So first we have this event that we have information like what is the curator of the organization, and we have the description, which means it's an event info, and we have the analyst, level, and distribution, and we have this tag. We can link this to event to be a same cluster or same group, and we have this taxonomy as actually define the tag, and within this tag we have multiple attributes that is defined by the object. That's a template for this attribute. And we can also see the correlation between different attributes and in different events. So our idea in this CTI work, that we have this, our motivation is that because CTI usually is and can be implemented in the like smart building, and it's really high, like really full of resources, and it's on the cloud. When we in all the other partner organization can share their strength information to the MISP in the center, and but because there are different kind of organizations such as telecom or hospital or bank, they have sharing different kind of data. So actually conventional methodology for cyber threat intelligence management is usually to be very expert involved, and it's really time consuming and prone to error, and they are really resource demanding. And as you can imagine that all this information comes from different places, so they may have some missing information such as threat level. Some people, because all this information are defined by the human, and there are a lot, so sometimes they couldn't really judge what is the threat level of this event. And sometimes its event can be missing. Information can be missing. So we have some missing information here. The goal of this work is to develop an extended version of the MISP platform that can include that we use machine learning models to support all this and to automate the management of this process of CTI data. So here is a framework of our CTI work. We call the MAS CTI. So first, we can collect the data from different sources. Like, for example, we can have the IoT devices. They can generate the alert. Then alert, we define our own sticks, but that is another work we're not going to present today. But here another format we defined, or even we can gather the other external resources such as sticks data. We can gather from other MISP feeds data. Then we also have some other custom data format that we can gather, and we generate a data sample from the IOC we received. And this data sample will fit into our 3 machine learning based model. First one is threat level ranking. Second one is event classification, and we have IOC clustering. All this after this remodel, they will output the result, and we'll aggregate all this result to generate a MISP format. And this MISP format will fit into the MISP core. And then we will use this different way to share this MISP information. So first of all, I would like to go through each module here. So the first one is IO suppressor and data sample generation. So first step, we need to recognize the format of the incoming IOC. So it could be sticks, it could be mix or other custom format, JSON format or other, our tiny sticks format. And we extract the value from these IOCs. And we identify if there's any information such as thread level embedded information are missing. And we use different feature extraction techniques to different formats. So for example, in this work, we have test with sticks format and we design this feature set. Totally, we have like 40, around 40 features. And this one we are generated from mix format and we extract like 66 features from this set. And then after the data sample is generated, we input this data sample to 3 machine learning model. First one is thread ranking. We use unbiased learning to rank algorithm to learn the rank of the threads. You can be sorted out which IOC is most important or most urgent. And so we can prioritize and rank the received IOC based on their severity, likelihood, or exploitation, or potential impact. And the second one is event classification. We design to classify type of threat, like I said, like could be malware, phishing, or DDoS attack. And we test it with multiple machine learning model. We test with CNN, convolutional neural network, XGBoost, and random forest. And we also integrate with federated learning that can enhance privacy preserving for the training of the models. And we also fed into our IOC clustering model that we can group similar IOC together based on common attribute or behavior pattern. And we assign this data sample to a cluster ID that can cluster IOC together. What is the goal of this model is actually when we share the IOCs, and we can share this IOC in the same cluster to the subscriber according to the cluster tag. So it can benefit the subscriber that if they are interest in one IOC, but they can actually perhaps some potential rated IOC can also see what can also receive the IOC that they are potentially related. So here comes the demo I have recorded, so we can demo for the CTI. Here comes to the right Cyber Threat Intelligence welcome page. We are using MISP, Malware Information Sharing Platform. They provide this graphic user interface to show their information. First, after we register to this system, we can log in with our email address. And the password. After we log in, you will see this dashboard with the list of events. First, you can see the rows. First row, in this example that we showed one attack information and it's created by us. In this demo, I will show you the procedure that we are getting the IOCs from the external resources, and we receive all these IOCs, generate the sample from them, and classification models and event classification model to predict the information that we need, and we generate the mixed format. We import this information to here, to this system. So let's begin. We can use our Python script and our input data set. It will take some time, but here comes the log. And as it shows, we are loading the test IOCs, and we are start generating the data sample from these IOCs. The IOCs is consisting by the numeral features, categoric features, and some text features. So we need to use different techniques to extract the feature from these IOCs. For the category feature, we are using embedding, like one-line coder, to encode this category feature into
higher dimensional feature set. So it will take some time. And for the text features, we are using multi-vector package that can generate the vector from the text. Okay, here are the categories features. For example, we have around 10 categories here for this IOCs. Then for example, we have antivirus detection, we have negativity, we have some information from the social network. And here are the attribute types. This is showing the type of the information we are going to share. For example, the destination IP address or the domain name of this information. And then they are generating virtualizing the text and the comment outer text data. And in total, we have 3,767 data samples generated. And each data sample consists of 66 features. And we load all the pre-trained models, such as event classification model, the threat level ranking model, and we also have the classroom model. After that, when we got all the information we need, we connect to the MISP. And here are the logs that we are importing all our information to the MISP. In this demo, we are only showing that we import 5 IOCs to the MISP. So here we come back to our browser. We can refresh it. Now we can see that there are 2 events are added to the dashboard. And one of it, we have 4 attributes. That is actually 4 IOCs. So we can get into this. We can see that these 3 tags are we generated by ourselves. There are the cluster IDs, and we also have the event class that is a malware we defined it. And this threat level is also the output from our threat level ranking model is defined by us. All the other information they are retrieved by the IOCs that is from the external sources. So here is the end of this brief demo. Thank you very much.
Yes, so I hope you can see it clearly. So sorry, let me continue this presentation. So to summarize this presentation, that we have implemented this extended version of the MISP. Then we address these challenges by using state-of-the-art machine learning models algorithm like strength ranking, event type classification, IOC correlation. And we also introduced a policy-based method for assigning level of confidentiality to IOC, ensuring data privacy and secure sharing in collaborative scenario. When actually it's a comprehensive integration between machine learning models, video learning, and CTI. This work is still under submission or under revision, so I cannot talk too much in detail, but hope you enjoy it. And so thank you very much for this presentation. You're listening.
Thanks a lot, Han. So we move to the Electron project, the Electron CTI platform for electric power and energy systems. We have with us Hristo Koshotansky from Atos and Pablo Calecos Jimenez from IDNet. Welcome.
Can you hear me?
Yes. Yes.
Okay, I hope you can hear me because I'm from mobile with the camera. If there's some interference on the voice, let me know. So thank you very much. Can we share slides, Esteban? Whoever can you share slides now?
I can see your slides. Yes.
Yes, very well. Me too. So very well. Thank you very much. I see them not in full screen, but I suppose
it's not in full screen yet.
Let me try, Hristo, because I'm having multiple monitors and it's showing the full screen and another monitor. So let me try change the monitor, if you don't mind. Just a second, okay?
No problem.
Okay, just a minute, just a minute. There you go. Can you see it? No?
No, I still see the slides. Okay, now very well. So, okay, thank you very much. So let me introduce, I will present you the Electron CTI approach. It's a CTI platform. It's more pragmatic and practical approach we undertaken in Electron. My name is Hristo Košutansky from Eviden R&D department, and my colleagues Pablo Gallegos and Esteban Armas will complement my presentation with additional information about the two components which form part of the CTI platform, and short demonstration, hopefully not video, will be a live demonstration of our technology. We share some similarities with anonymization from the previous approaches and some CTI scoring relevance from the presentation of the AI approach before that. Okay, so briefly, what is Electron? Electron is for resilient and self-healed electrical power nanogrid. So here we are talking in the domain of energy. The power grid infrastructure needs to be monitored and needs to be protected. We have in this context three main workflows within Electron. Let's say the CYPER, I hope the CYPER, yes, the CYPER workflow, which is about the detection and normal detection, intrusion detection, so information coming from detectors. And we also have a vulnerability information that regards the different devices and communication protocols in the power grid domain, and also additional threat intel information that may be relevant for the given EPS operator. Power grid operator. So this information is used into the border workflow, the components on the top, where they, based on the vulnerability and CTI data and the ongoing attacks detected, anomalies as well, they calculate risk and mitigation actions. So we've also seen similar approach in previous presentations. So the risk here estimates the impact and the risk that attack may cause in the cyberspace. So we have here cyberspace and the OT space in the project. So the border framework estimates the risk on the cyberspace and the impact may cause on the power grid, on the specific nanogrid, and the baskets, substation bus communications there may occur. And then to summarize, then the bridge framework, it's another set of components in the project. They are in charge of providing the mitigation on the cyberspace, ASDN technology, so we can control and monitor and the network. So we need to enable some ASDN enabled components needs to be there to make the cyberspace mitigation actions applied on the substations communications. And also we have in the bridge framework, we have the workflow, the mitigations on the OT space, which is important. So from the cyberspace, detection of attacks or vulnerability information is used to trigger some eventual mitigations on the OT space, on islanding, for instance. If there's under attack, specific part of the subgrid needs to be isolated or reconfigured so that the electricity and the energy is not disturbed and the attack is mitigated, the impact of attack is mitigated to the extent possible. Next slide, Esteban, if you can go there. So, the information sharing in energy community. So there we have also we have two components. Let's say one is the CTI SharePoint, which is allowed to so for an operator to receive information and to share information with the vulnerabilities from its domain, from its infrastructure that is operated by the operator. It's the SharePoint, actually CTI SharePoint is used to do enhanced anonymization and security, enhanced sharing as well. So you can encrypt part of the data, part of the MISP object that you want to confidentially share with some other stakeholders, while other part of the MISP object data can be freely shared. So you have this flexibility and utility on the SharePoint, on the CTI SharePoint that we can name it. Another component relevant for our approach in Electron is the Threat Explorer. So what we need here is a requirement is to extract vulnerabilities from the public open source intelligent resources, so on a regular basis. So we need that information on our platform on a regular basis and need to have to offer anonymization and security enhanced sharing with other stakeholders. So this is the key characteristics, let's say, in requirements. Okay, so as already we've seen, we use also MISP technology in the backend to integrate with the other stakeholders infrastructures, MISP infrastructures, sharing nodes, let's say, and we have a front end which allows us to actually visualize, not only to visualize, but mainly to provide some security policy specification that allows to encrypt and controls what levels needs to be confidential, what fields of the object needs to be anonymized when shared, and thus these are the preferences of the operators. And we have CTI scoring, which is objects needs to be known. So an operator needs to know what, how much vulnerability, for instance, is relevant for each type of assets, devices, software, hardware. As we have seen even in the first presentation of CrossCon, there is also a range of vulnerabilities on the very low level, which is on the IoT platforms, and T is there. So all this information is really needed for us to find first relevance to the given operator's infrastructure assets. And the Threat Explorer, as I said earlier, we need that information on a daily basis to be retrieved and given to us to our platform. And that needs a suitable architecture in behind to make such scheduling for vulnerabilities retrieval from public repositories. And what we also need here is specific data. We're not interested in more generic data. We need specific data for the operators. We know that in the power grid substation communications and automations, there are a number of industrial protocol for communication, so for monitoring and controlling substation components and equipment and processes there. So this is IEC 104. The European standard DNP3 is more for the American, Latin American, and US standard for substation communications. Modbus, well-known OTA protocol. The IEC 61850 is also a very important protocol, which we also requested and need vulnerability relevant for such protocol implementations. We have different device manufacturers. So this is specific for the power grid domain requirement that we need on a daily basis to be retrieved and given to our platform. Okay, so probably that's from my side. I will now pass the floor quickly to Pablo Gallegos from IDENR. He will briefly present the Threat Explorer component, and that will be later followed by the short demo of our CTI platform. Pablo, would you like to join here?
Can you hear me?
I can.
Okay. Hello, thank you very much, Risto. Well, I'm going to tell you a bit about the Electron Threat Explorer. As Risto has said, the main objective of this component is to discover and analyze vulnerabilities that has been discovered that can affect to the Electron domain, concretely to the EPS operator. They use Crawler and OpenAPI to read and crawl different website and database that are related to cybersecurity and publish this information. Of course, it can be configured to different way of work, but we have this analyze and see that analyze this data source every 24 hours is the better way to do it. And once this vulnerability has been analyzed and decide if they are relevant, are shared with the Electron SharePoint that will be explained later by Esteban. That also is going to inform relevant Electron component and trigger some mitigation process if it's necessary. Next slide, please. So one of the most relevant way of work that we have analyzed is that the end user thinks that vulnerability signs 2020 are still relevant. So we have analyzed all this database and we have gathered almost 600 vulnerability that can affect to the EPS domain. We have tested two different approaches to evaluate if they are really relevant for us. We start with machine learning, but the results were not pretty good because it needs more resource and more time to need similar data than the other approach. probably it's because there are no good enough data set to train the model. So we have changed the approach to some keyword-based expressions. So we have analyzed the vulnerability in the last few months, the last few years, to see which words are present in all this kind of vulnerability that can affect us. And we have put a set of keywords that can be, of course, modified and can be incremented in the future. You can see here the list, but as I said before, some protocol really important and some specific device. So next slide. As you can imagine, there are a lot of website database, open source intelligent database that can publish this information. During the development of this component, we analyzed almost 50 different data sources, and we achieved the conclusion that we only want to analyze that one that were the first to publish at least one relevant vulnerability for us. So here you have the list that we are working on. Of course, this list can be add more resources if they are fine, but in our analysis, no new vulnerability will be added with other data source. So next slide, and I think it's all from my side. So Esteban, you can follow with the
Yeah, sure.
SharePoint.
Thank you, Pablo. Thank you, Risto. So let's jump into the SharePoint. SharePoint is a component of the Electron framework. We work hand in hand with the Threat Explorer, basically, to come up with this solution. The SharePoint itself has two main functionalities, basically the sharing and the enrichment of the event with the score calculation that already mentioned Risto. So the enrichment and scoring or scoring basically means that we calculate a risk or a threat level score based on different heuristics that we managed to get from the vulnerability objects from the miss event. And then based on the requirements of the Electron solution or the Electron project, we map those vulnerabilities to the assets that the client or the pilot owner provides of their own network in order to enhance the capability of the solution for the analyst to review the threats that are more focused on their own topology, right? So that is regarding the event enrichment. So the sharing capabilities of the SharePoint basically means that we ensure the confidentiality of sharing CTIs among MISP network by anonymize the IOCs using Masquerade basically, and also we encrypt those other IOCs that wants to be shared on the network to be only read and used by those users, organizations, or roles involved on the network. So basically, we fine-grain the solution of sharing information among different organizations up to the level of users, individual users. So regarding the types of objects that we currently analyze, at least on the Electron project, we can use and analyze, as I say, vulnerability objects, putting in red the ones that are required and the others that are in black are optionals. Then regarding IOCs related to IP addresses, then we also can use, encrypt, analyze, and share file objects. And since we want to be on the critical infrastructure types, not only the electrical ones, but also the financial sector as well, we can also use and analyze the financial objects such as BTC wallets and other informations. Regarding the CTI scoring, as I say, we use different features, different heuristics to calculate this score. We mainly use those four that are presenting on the slide: the relevance related to the relevance on the topology of the end user, on the owner of the instance in this case, the trending of the IOC, of the vulnerability object in this case, we use the Google Trend API in order to quantify the trending of that particular vulnerability on the internet and put it on the score based on that. Then we also check the timeliness of the IOC or the vulnerability score is on the vulnerability score, the vulnerability object. And then we check the completeness in order to quantify how much information, how much context the object brings to the system, right? So let's go with the demonstration. Okay, so let me share my other screen. Bear with me. Just a minute. Yeah, I think that this will make it. Just a second. There you go. I don't see the screen to share. There you go. Can you see my screen, please?
Yes.
All right, thank you very much.
Yes, we can.
So here we have the Electron MISP instance, okay? We have, as already mentioned, several vulnerability objects and vulnerability events related to the electrical power infrastructures, okay? Our SharePoint is this one, okay? We create a graphical interface in order to facilitate the interaction between the users and the sharing information and read, of course, the encrypted and anonymized information. So let's log in and let's work with a typical example of sharing messages with Alice and Bob. Okay, so basically what we want from Alice is to share an MISP event that contains critical or private information, right? And we want to share with Bob. So in order to do that, first we need to select Bob as the receiver. Then if we want to modify the ways that we are going to share these IOCs, for example, we want to encrypt this particular IOC, we want to anonymize this other one, if we want to encrypt this other one, and if we want to left as a clear text the last one, we can leave it. We also can define the time window in which the user can read, analyze, or use the IOC. So for the example, in this case, we want to be accessed by Bob up until tomorrow. We also can add some different tags for the event to be more accurate. So let's add this one. And then we can share this event. If we can to the instance, we can check that the new event is already put it. I'm sorry, this is because I didn't put to encrypt this one. So we want to encrypt the information so we can create another one. Okay, so there you go. Sorry, that's the online issues. So as I was saying, so if you can see the event that we shared before, it's on plain text, and the other one, the new one that I already put to be shared by encrypting the info of the event, it's not human readable. So also the other parts of the event are already encrypted and useless for anyone that wants to be that wants to analyze or read or came up with this bump it up in this event. But if we go to the account of Bob, we can check that we already received 2 events in this case. The first one, the one with the 32 ID, is the one that it was the info in clear text, and the 33 is the one that is an encrypted info. So we can go in there and check those IOCs that we encrypted to be shared already decrypted, and the information can be only accessed by the user that we want to share with. So it's not easy for other ones to access those IOCs because we use something that we call sharing agreements, in which we ask that particular information to be used by our platform and to ensure and secure those information that we want to share with the rest of the organizations. Regarding the types of information that you can find on our MISP instance, in this case, for example, regarding the score that we were talking about earlier, this is the score of the threads based on the analysis of the different information that already mentioned, the 4 heuristics. We put it as an attribute, and also we added as a taxonomy for in the instance to be easily to categorize and access by the analyst. Also, we use different taxonomies based on the type of industry, based on the type of vulnerability, based on the type of threat as well. And the mapping of the threat based on the infrastructure that the client provides is also included as an attribute to facilitate also and to quantify the possible impact that this vulnerability could have on the network of the client at the end. So this is what we can mention about the SharePoint platform of the Electron project. So if you have any question, please don't hesitate to ask me. Thank you very much.
Thanks a lot, Esteban, Cristo, and Pablo. And now we move on to the next presentation by the project ITA. We're going to listen and see the demo of the Heimdall tool, dynamic threat detection tool. We have with us Unai Sandy. Welcome.
Thank you, Christiana. Let me share my screen right now. Okay, here. Can you see my screen?
Yes.
Perfect. Well, thank you, everyone. Today I will talk about Heimdall, a dynamic threat detection tool. And I will briefly introduce the IDUM project first, where it's being developed, the Horizon project where it's being developed. Then I will make a brief explanation of what the purpose of Heimdall is and what the tool offers. And then I will explain its main 2 services, the Asset Manager and the Virtual EDR. After this, I will showcase a small video that shows the main functionalities of the Asset Manager. So to begin, let me just, okay, there. I couldn't see the screen because of the TeamViewer. So IDUM project, the title of the project is a cognitive detection system for cybersecure operational technologies. And the main objective of the project is to develop a tool chain of, in this case, 5 different tools that work together in tandem for the securization of operational technology environments. To begin with, the first tool is Samora, which is a subscription reporting and alert service. And the main purpose of Amora is to offer traceability of the assets that are being monitored in the OT environment. To do this, it breaks down the contents or the different components of the assets to be monitored and stores them in an DLT in order to keep traceability of how they evolve over time. Then the second tool is Heimdall, the one that I will be explaining today. And its main purpose is to be a vulnerability search and detection engine. it offers two main services: discovering vulnerabilities in managed assets via analysis of SBOM files, which I will explain later on, and it also monitors network traffic to identify anomalous traffic and incidents. This is done using machine learning algorithms that are trained beforehand. Then Thor is a real-time analytics and prediction system, which uses web crawlers both in the dark and clear web to collect different indicators of compromise or indicators of an attack, and stores them in a data pool, in a data lake. And this data lake is then accessed by an analytics service, which offers querying and querying service that allows the further insight into the collected data and different attacks that might show up. Then Odin is the module or the service in charge of the response to security incidents. And in order to do this, it employs different orchestration and threat management technologies, and the main one being SOAR. And then because it's using SOAR, it has three main different modules: an orchestration, an automation, and a response module. And the orchestration module receives data from different sources like Thor, Heimdall, and third-party sources. And then it sends this information to the response module if an attack is detected. And then Frigg is the last tool in the toolchain, which offers visualization services using Kibana and Elasticsearch. And then there is also an extra service, which is a data generator, which offers the creation of telemetry data that can be used to train and test the other existing toolchain components. So these 5 tools working together aim to offer a secure operational technologies environment. Making this brief introduction, I will go further into how Heimdall works and its main purpose. And Heimdall focuses on the detection of vulnerabilities, like I mentioned, especially in the OT environment. And one of its main objectives is to minimize the impact of the monitored network. Since these services usually offer critical services that shouldn't be interrupted or slowed down during its process, Heimdall tries to look for systems that avoid any delay in the workings of in the normal workings of an OT environment. To do this, first there is the Asset Manager service, which detects the static vulnerabilities that might be present in the environment. And to do this, there is a vulnerability and exploit database that's cached regularly every day, querying public databases that are on the internet, such as NIST's National Vulnerability Database. With this collected data about exploits and vulnerabilities, the asset management system takes the different assets and their components and checks them against the database of vulnerabilities. And if any vulnerability is found, an alert is generated both to Odin and to the system managers. Then, after this, there is also the more dynamic side of vulnerability detection and attack detection, which is a virtual endpoint detection and response module, also shortened as a virtual EDR. The virtual EDR monitors the network traffic and tries to, through a machine learning algorithm, detect if there is any anomalous traffic going on in the network, and it also assigns a score to how sure it is if this is an anomaly, and informs Odin that an anomaly has been detected in order to trigger a response. So with this brief explanation, I will explain more how the asset manager works exactly. And the main issue that it tries to respond is that when an environment is set up, it's pretty complicated or pretty complex to know if a vulnerability exists in the tools used in the network in general. So especially when the stack is comprised of many different technologies, software providers, etc. So once a network is set up, the first step to detect vulnerabilities usually can be doing a pen testing or trying to track down the existing vulnerabilities that are public so that they can be fixed. In order to do this, the pen testing solution obviously is pretty time costly and expensive. So trying to automate the collection and comparison of the public information can be sometimes faster. Heimdal does this by taking information from the network server via SBOM files, software bill of material files, and then using the public information that, for example, you can find out about Cisco or Ubuntu 18.04. This information can be extracted and applied to the network. So, for example, when a network is first declared, a certain number of vulnerabilities can be found for each different component of the network. And
I think we have already discussed it in the previous meeting that we had. Can you hear me?
Yes, tell me. Yes? Sorry, I have the full screen and I can't see who's talking, but did you have any question or?
I think that the participant didn't mute his microphone, so it's not a relevant question.
Yeah, my bad. Thank you, Christina. Well, the objective of this vulnerability management is to make sure that over time, no new vulnerabilities are appearing in the system besides the ones that are already known. So if a new one is detected, it should be reported to the network managers so it can be addressed, either accepting the risk, the potential risk, or trying to manage and fix it. So when, for example, an initial scan is done on the network server, a certain number of vulnerabilities might exist. But for example, if the next day a new vulnerability is published in the NIST, by the NIST, then it should be added to the existing vulnerability count and addressed by the system overall. So once that information is collected, not only the information about the software components that are present in the server or the network and the vulnerabilities detected, that information can be exported using an SBOM file, a software bill of materials file in the Cyclone DX format, one of the main standard formats together with SPDX. And this should help information to be more readily accessible to the network administrators. To further increase this, one of the main purposes of the Cyclone DX SBOM file is that it can represent a wide range of different devices. And with this, we expand how much Heimdal, where the types of environments where Heimdal can be deployed. So this is the main purpose of the asset manager. And then the virtual EDR is as I mentioned previously, the network monitoring tool. And in order to minimize the impact that this constant analysis has on the network, especially on the communications, this analysis, the network traffic analysis, is done outside of the surveilled network. So in order to do this, you can see on the first step that we have a network under surveillance, and using port mirroring in a network switch or router, we also duplicate the network data to the network where the virtual EDR is. With this, we are not putting an extra step in the network process, but we can still conduct the data analysis. So firstly, when the port mirroring is done, it goes to a Suricata server, which contrasts the information or the data with the rule set in order to block malicious data that is already known to be malicious. And after that, that information is sent to a machine learning model with a different host of different microservices that interact all together in order to detect if there is an anomaly in the network data, and if anything is detected, it is sent, that information is sent to Odin via an AMQP broker. So Odin can then, after receiving this information, can decide if a response is needed in this case, and if the response is required, it will send a message back to the broker to the virtual ETR and will create an extra rule in the Suricata broker or in the Suricata server so that it can block that data further on. And after this process, this continuous process of network monitoring, the rules that are created and the current rule set can be exported to CM and SOC services. So this further helps the creation and maintenance of that monitoring service. Then I have the Heimdall demo, and to try to stick to the scheduled time, I will go briefly over different parts of the demo. Okay, so here you can see Heimdall's main dashboard, and it has two main parts. One's the asset manager service, where you can see, we will see how assets are defined, shown, and managed. And then there is a catalog that allows to query the data, the CVE, the vulnerability data, and the different product data that is currently stored in the Heimdall cache. So first, this basically shows the CVE data briefly. And as you can see, there is like 200,000 vulnerabilities stored in the database currently. And it shares an ID and a score, a vulnerability score, which would indicate how much of a threat it could be to the server. So this is a further detailed view of each vulnerability with a description, CVSS data, and more a detail of the weaknesses. And then the CP service shows the different products that are stored in the database. So whenever one of these identifiers is added to the Heimdall search engine, its vulnerabilities will also be shown. There is also a search service that can help, especially looking for a specific vendor products like Siemens in this case. No, my bad. Like Siemens in this case. And after this, the asset manager functionality is shown, okay? So briefly skipping over it. Here, my bad. Here we can see, for example, the current 5 assets that are being monitored by Heimdall, along with the vulnerability numbers that are detected currently, and how many components are declared for each one of the assets. And the latest snapshot status. The snapshot stores if the analysis is currently in progress, if it has failed or succeeded. So whenever the analysis is conducted, once we access the asset itself, we can see different snapshots. So the status of the asset during each SBOM update, and then a list of all the components that are declared along with the individual vulnerability numbers. Okay, so then we can reduce this view to the actually vulnerable components and a list of the total number of vulnerabilities found and managed. And lastly, there is a tab for suppressed vulnerabilities, which would be those that either don't apply to the network because of some conditions that must be met, or because it was assumed as an accepted risk. Okay, so this is the main screen of the asset manager, and this section explains how the creation of a new asset would work and how an SBOM file could be exported. So this is the asset creation screen, for example, where you could enter basic information about the product. And then For example, once the empty project is created, empty asset is created, an SBOM file can be imported in order to take all the components declared there and search for their vulnerabilities. So the video imports the SBOM file and then skips over to, well, it says here that the analysis is in progress currently. And then further on, we can see that the components have been imported correctly along with their CPE identifiers. And when we go to the main screen, we can see the asset along with the other managed assets and with the status. If I skip a bit ahead, we can see that after a refresh, the analysis has been completed and the number of vulnerabilities has been shown on screen. And if we access the screen, the information screen, we can access all the information, the vulnerability information further on. And if I'm not wrong, that's the end of the demo, of this short demo showcasing the asset manager. Since the virtual EDR is harder to show it's working with a managed network and so on, we decided not to show it here, but we are currently working in a demo presentation as well. And this has been everything from my side. This is my contact information. If you have any questions further on or want to know more about IDUN project or Heimdall, and I will be very glad to answer any questions you might have later on. Thank you, everyone.
Thank you very much, Mai. And I am glad to welcome my colleagues, Anaela Bihan from NTT Data and Arnold Spiros from CERT, who are going to present the second project, AI-based cyber threat intelligence in healthcare ecosystem. The floor is yours.
Hello. Thank you, Christiana. Can you see my screen? I'll put it full screen.
Yes, yes.
Okay, great. So, well, it's the last presentation, so we'll try to be fast so we don't delay too much the event. So, I'm Anaela Bihan from NTT Data. We are coordinating this project, and I'm here with Arnold Pierce, who is from CERT, and they are the scientific coordinators. So we are going to introduce quickly the project, so security and privacy protection in Internet of Things devices. Okay, so I will present very briefly the project, then my colleague will present a demo. Okay, so first of all, this project is a 3-year project. It's financed by Horizon H 2020. We are 19 partners from 9 EU countries, and it's a well-balanced public-private partnership. As you can see, we have many ICT industries, SMEs, research institute and universities, healthcare organization, and also one European CERT. Okay, to give you some context, why we've done this project. So the industrial sector is experiencing number of changes in the last years. So there is new models of remote delivery, especially in complex ICT infrastructures, which increase the potential the potential impact of cybersecurity breaches. Also, the level of security awareness is still very low compared to the potential of security breach in critical sectors. Here in second, we are focusing on healthcare. So it's a sector which is constantly increasing data-driven ecosystem with sensitive data, which is critical. So the need here is to understand the risks and to complement traditional platform-specific and attack-specific countermeasures. So what is the main goal of Secant? So our goal is to develop an automated threat detection platform to identify threats and attacks while promoting the situation security awareness as a priority. For that, Secant has 4 major pillars. We have, as you can see, digital security and privacy, data protection and accountability, collaborative threat intelligence, and cybersecurity awareness training. For direct end users and stakeholders in the industry, it could improve the cybersecurity. It could also increase data protection. For example, adopting a digital security solution as well as security training. So for the second platform, it will be validated thanks to 4 use cases. So the first use case is, as you can see here, is about protecting the connected ambulance of the future. So here, the aim of this use case is to validate Secant ability to improve transportation safety and to ensure zero error delivery of patients' transportation. The second use case will be more developed by my colleague Arnold within the demo, but basically just to let you know that this use case will serve to validate Secant's efficiency to deal with cascading effects of cyber threats in connected healthcare infrastructure. Our third pilot aims to validate the capacity of Secant to ensure data protection when operational data is exchanged within the healthcare supply chain. And finally, our last use case aims to validate the capabilities of our second platform, cybersecurity training modules. Okay, something also we want to highlight here is the innovation bring by Secant. So the main innovations of Secant are to develop innovative risk analysis methodology, also to offer real-time information sharing capabilities, also to introduce innovation in the field of trust and accountability. And finally, we want also to highlight that one of the main innovations is to allow to protect technologically connected organization and their user. Okay, so thanks a lot for that. Just to let you know, we have here some contacts, so do not hesitate to let us know if you have more questions. And I now give the floor to my colleague Arnold. Thanks a lot.
Hello everyone. Thank you, Anael. I hope that you can all hear me well. So I will start sharing my screen, and please let me know if you are able to see it.
Yes.
Okay. So today's demo will be in a video, and I will explain as the video goes by, and we will see the threat intelligence module of Secant, which is the module which is responsible for gathering, analyzing, enriching, and finally sharing cyber threat intelligence within Secant. So among the tools of Secant and to the external stakeholders. So starting here, we have the dashboard of the threat intelligence module. So we have 3 main crawler categories here. We have the web crawlers, seen here. We have then the social media crawlers, which comprise of the Reddit crawler and the X, formerly known as Twitter crawler. So starting from the web crawlers, here we have the main user interface. We have here, starting from the upper side, the URL that we want to crawl. It is a target URL. And here we can apply different settings before we actually start calling the source. So we can filter by domain, which means if the crawler identifies hyperlinks which refer to different domain within this target URL, it won't go there because we want to stay in this domain. Then we have the depth, which counts the slashes that we want to go in, how deep we want to go. So here, for example, we have 1, 2, 3, and 4. The depth is 4. We can choose to monitor this specific source in terms of days. We have the focused crawler here, which basically filters the content of this target URL based on the threshold that we have. So the filtering is done in terms of its relevance, the content relevance to the cybersecurity or CTI domain, based also on the threshold that we set. So 0.1 means 10%, 20 means 2 means 20%, and etc. until we reach 1, which is 100. And finally, we have the evasive crawler, which simulates human behavior. So in this way, we can gather content from the target URL that the actual human would view in his or her browser, because some sources provide different content to crawlers and different to humans, meaning that for crawlers it is more high level, while for humans the information is more rich, and this is what we want here. Okay, so we crawl it, and we will see that on the downside it appears in the history. The status is running. We can delete it. We can see some statistics, choose some settings or stop it. If we want to rerun it, we can rerun it using a different set of settings, which have the same settings available as explained previously. We can see some statistics here, and they are updated as the crawling goes on, and some statistics are not applicable until we gather a sufficient amount of content, or it depends also on the type of the content that we gather. So going back to the dashboard, to the main dashboard, we see that our web results here are increased to 2. We have gathered one more web document from the crawling that we just done. And here in the results, we have also several options. So we can search for a specific keyword in the results if we want to limit our results to a specific keyword. So here we tried the ransomware. We found 3 documents. We can sort it by several options and choose the sorting direction in ascending or descending order. Okay, so this is for web crawlers. Now we move to Reddit. In Reddit, we choose the subreddit name. We have fewer options, but they are more or less the same as for the web crawlers. So they're focused on the monitoring. And the last one that we see here, the 10, is the number of posts that we want from this subreddit. So we have already ran for cybersecurity. So let's run it for CV Watch. We set the threshold to 0.1, so we want the relevance of 10% to cybersecurity, and we want to limit our crawling to 2 posts. Okay, similar to web crawlers, it appears down here. We can again crawl it with different options. Okay, and once we click here on the sorry, the keyword, we can go to the Reddit crawler dashboard, and we can see the results that we got back. So for CV Watch, we actually see here 2 posts as we selected. We want only 2 posts. We see here also the first post has 2 comments, the second one has 1 comment. And for our previous search for cybersecurity, we chose 10, so we have 10 results and many comments. So 137. This is an issue if you want to analyze it, because there are too many. So what we can do is apply a threshold here. So we can, similar to the focused crawling, we can apply a threshold later here in Reddit. So we set it to 79. So we want 79% relevance to cybersecurity. So some comments are now filtered because they are not relevant based on the threshold to cybersecurity domain. And we can see that the usernames are rectified, of course, for privacy reasons. Okay, now moving to X, we choose specific keyword that we want to search relevant tweets for. We already searched for cybersecurity. Now we search for vulnerability. Okay, the status is running. Here we don't have any options. We just apply the keyword. We use the official X API here. And we get back the results here in the dashboard. And if we click here on Reddit, it moves us to the Reddit results. We can click it again and go back to the Reddit view. So all this information is of course gathered and available visually to the user, but we need to actually make it cyber threat intelligence from cyber threat information and enrich it further, increase its ability to be more dynamic, actionable, and add it in a data storage. So similar to other projects that we saw today, we use MISP as a basis for our data storage and for making the CTI available. So we refresh it, and we can see here in MISP that we have several type of events, MISP events, or otherwise entries if we don't want to use the terminology of MISP. So let's see what these types are. So first of all, we have, starting here from the beginning, we have the Reddit results. So here is the cyber security. We have 2 entries for this. We have the results from web crawling. We have the results from X. So we have this, for example, tweet stopped here. And then we have CVs, different CVs, which are gathered on daily basis from the official NVD database. And for some entries, as we store them and they are analyzed, we can see that we have some here taxonomies applied on them based on their content. So this is done in a dynamic manner because we have the dynamic taxonomy generation in adaptation in second. So what this means is that we are able to either update or create new taxonomies in a dynamic manner and assign them in a dynamic manner to the content which is part of the enrichment. And the other part of the enrichment is the simple and advanced correlation that we do, that we apply on these entries, where we search for similarities, either string-based or using AI, choosing specific features to see if there is any similarity among the entries. So let's go to each type of entry. So for CVs, we have all the information that's available on NVD. We have the ID, when it was published, description, references, and CVSS scores, of course, whenever available. Okay, so for tweets, we have the post ID and the actual tweet that was gathered. So moving to Reddit, we can see here that it is currently empty, but the analysis is ongoing. So we see that everything is done in a dynamic manner, and it will be the information will be added at the later stage. And going to the results from the web crawler, we see that we have here the domain that was crawled, the actual URL where the content was collected from, and we have the actual text. So in case the text is long, of course, we can click the show all, and we see it in free text format. So we don't have the hyperlinks and other HTML formatting available, but we have the actual HTML formatting available back in the web crawlers dashboard that we saw earlier. And yeah, this concludes the demo. So thank you all for your attention. And we are open to any questions that you might have during the Q&A session.
Many thanks, Arnold and Anael. We are open to questions for the 4 projects that presented their demos. Arcadian IoT, Electron, Eden, and Secant. Your feedback is important. Any questions should be directed to the respective speaker.
I may have one question from my side, speaking. It's just, of course, I was from the presenters in this session. So sorry, just from my side, to me, a main takeaway for today and for in the afternoon session is about the AI. So we know CTI, threat intelligence and vulnerabilities, deficiency in these models, they might be appearing a very promising domain of research and investigation in the upcoming years, understanding, for instance, what metrics may be used to generate CTI for specific type machine learning algorithms, models that are used. For instance, an operator of a system, and any of our projects, we use heavily AI. Practically in every component, if I'm not wrong, from today's presentations, they adopt AI. So my question also was to the speaker of the Shen from University of Dublin College. So how these metrics there can be used for CTI threat intelligence generation?
I think Mr. Shen left a couple of minutes ago. Yeah, he mentions in the chat, in the call chat, that he had some lectures to attend to.
Okay. So to me, this is a relevant point because the heavy use of AI nowadays actually implies also how much CTI data for the AI models there can be generated and factored out in our systems, so that we can also get some intelligence for that.
I think Arnold would like to add something on this.
No. So it's just raised on 4 questions later. Yeah.
Okay. Christo, thank you for your feedback on this. I don't know if someone wants to add a comment.
There's no need to be added a comment here. Just that is a remark that trustworthy AI means also a sort of intelligence we need on that and to be processed by our systems and be connected with other components, because it's not enough that you have vulnerabilities or intelligence on other type of components, but AI itself is not covered. Okay, thank you anyway.
Thank you. Yes, Arnold.
Okay, so I have several questions. I'll try to be as quick as possible. So I have 3 questions for the Electron project. So I saw that in the sources there were URLs and considering the domain of Electron, I would like to ask how easy it was to find the relevant sources, relevant URLs for this domain.
Hello, I think it's for me. Well, being honest, what we are looking for is for a relevant data source from any domain. And after that, we process the different vulnerability and the different data from each website to see if the new vulnerability is related to our domain, I will say. So we are looking for all the data sources that are public, and after that we filter, I will say.
Okay, understood. Thank you. And for the keywords that you use for the filtering that you described, how you selected these keywords? I mean, it was derived using a specific process. It was just a brainstorming.
It was more than one phase process, I will say. The first one was to ask the end user if they can give us the main words or the main protocol that they are already using. After that, some of the technical partners that are working in the project has a brainstorming and added a few more. And after that, what we have done in, well, Risto and me and Esteban mainly, we have checked all the keywords and has looked in the different website the vulnerability that has this keyword. So we have more or less studied the accuracy of this keyword to see that more or less 80–90% of the vulnerability that has this keyword are relevant for us.
Okay, thank you. Really interesting. And the last question for Electron will be, so I saw that you have several sources, if I'm not mistaken, for CVEs, for vulnerabilities. So how you deal with the duplicates from these different sources? Why I ask this? Because okay, having a CV with the same idea, I mean, it's easy to identify that they are similar. But how do you actually check, you identify a duplicate and you choose which one to keep, which one is updated, the latest. So how you deal with it?
I will say that now we are only using the CVE to identify. So if there are different CVE to address the same vulnerability, probably we will have the duplicated in our database.
Okay. Thank you. So if I may, I also have one question for Heimdall.
Yes.
Okay. Hello, Nay.
Hey, Alan. How are you doing?
I'm fine.
Long time no see.
Hope you're doing well. Okay, so I saw that you during the demo you shown that you use CPEs. So you add the CPE and you identify the vulnerabilities. Okay. If you don't have this information, I mean, if you don't have the CPE or the vulnerability doesn't have this information, because some vulnerabilities don't have specific CPEs, as you probably know.
Yes.
How you deal with that? I mean, can you do the mapping otherwise, or?
Yes, in fact, CPEs are they are really compartmentalized. Each field can be filled in to try to make a query at least. So one of the early attempts that we are currently doing is and we did just like you mentioned, we did that besides checking the National Vulnerability Database, try to check other open source vulnerability engines or the databases like OSA, Google's open source vulnerability database or GitHub advisories. And these don't often use CPEs. One identifier that they might use sometimes, it's the package URL. So package URL is one of these product identifiers that it's being currently considered to be included in the CVEs. So Mitre, it's currently, I think, going to be released in the next set of, now I'm getting foggy with information. It's been a long time since I looked it up, but it's going to become information that's going to publicly be added to the CVEs and to the vulnerability information. So we are hoping that at least when we to include package URLs besides CPEs to try to broaden the catalog of possible products, since the CPE is also pre-hand maintained by the NIST. Package URL, on the contrary, is free, so it's public, and any GitHub repository could be represented as a package URL. So this is one avenue that we are considering to tackle that lack of CPE identifiers. I could send you more information that we found back then if you are interested in that kind of identifier.
Sure, please do.
If you can send me your email, or I think, I think maybe on the, I have it available on the mail that they sent before. Just.
I can also put it in the chat if you want.
Spiros@it.gr, right?
Yes.
Greece. Okay, perfect.
And, okay, so you consider also a vendor specific vulnerability databases?
The other vulnerability databases that we considered were Google's open source vulnerability database, GitHub advisories, which are maintained by GitHub, and Sonatype's OSS index. Sonatype is really interesting because they try to use both package URLs and CPEs for their querying, but they focus on package URLs. So, and it's a pretty complete database that works quite well with NIST's National Vulnerability Database. So I think it's one avenue that we considered back then, but left it aside since it wasn't a project's priority, right? Including more sources, but it is something we are willing, or we want to look more into it in the future. Yeah, and if you want, I will send you all these databases, their URLs. In our experience, just so you know, the main problem with GitHub advisories and OSV is that since they are open source vulnerabilities, sometimes the information that these vulnerabilities contain can be quite incomplete comparing with NIST's CVEs and so on, since both the ID system and the information they contain can be more dependent on who is publishing that information. Okay. And since it's public, there is no strict control on this, except on GitHub, which does handpick some CVEs and complete, and I don't know how they call them, but officially review them or some in some sort of way.
Okay. I'm more than covered. Thank you. Waiting for your email to get more to that. Thank you.
Sure, you're welcome.
Any more questions for our speakers? No? Okay. So we have reached the end of our workshop. That was a massive one. 9 presentations from 9 EU-funded projects. We hope that they were interesting and valuable to all of you, and that they have provided insights into the cyber threat intelligence and its integration within various vertical industries. Thank you very much again for your participation. Thank you to all the speakers and for all the patience that you showed. I know there was a delay, but I think it was worth it. And I wish everyone a nice day ahead.